right, so welcome to System Analysis and Design at the second time lecture through Chapter 4 having to do with process modeling. In Chapter 4 assignment, we answered a variety of questions from the end of the chapter. And as we go through the presentations I have here, I want to make sure we answer these questions for you. So while you're watching this, you can start up the document. If you want to use Google Docs, you're welcome to, and then just download it as Microsoft Word once you're done with it in Microsoft. And remember, I'm looking for a professional memo style, not MLA. MLA is not how you write memos in business or technical documents. MLA is ugly for technical documents. So I'd show you, here's how I might actually start this document. I got to get signed back into my system over here. And go over to my CS412 files here. We'll be looking through the PowerPoint provided with the book, but I've added a few pages to it. It's about requirements modeling. And remember our waterfall diagram. We're done with planning. Now the goal is here in this requirements or analysis phase is figuring out what are the system requirements. And to do that, we're going to talk about surveys, also being specific on what are your system inputs and outputs, because that is one of your questions on the assignment is, what is a system requirement? How are system requirements classified? These questions aren't going in the order they were presented in the chapter. They get to the questions towards the end of the chapter. They talk about requirements at the beginning. So let's take a look at that first. Again, to systematically document how you're designing your system, you want to lay it out in a clear list of requirements. Some systems you're designing, it's like, well, why do we care about that question when I'm doing a website or I'm installing a server? The output. What is the output, for goodness sake? Well, these are the general areas, and if you think about it in these areas, you should have covered most of the things your system's going to do. So when we think about these questions, which is, what was the question about? What is a system requirement? How are they classified? So those are the classifications, those 5 areas. So that gives you your first, or half of that question, how are the system requirements classified? Where you have output, what kind of information does your system produce? What information is entering the system, being processed by the system? They use the general term, it's transforming the data. A good reason to even have your system is there's something better in the performance. Having to do with the speed, how much data it can process, or materials, if it's a material handling system. Will it be more available, or maybe it's the first install, it wasn't available before. And then, what kind of control is there on the system? Security is a big deal for everything. So I was thinking of in terms of a project such as I'm installing a server because I've become a server expert, and part of the installing of the server is to actually become an expert in Windows Server. Well, what would the server system, let's think about that specifically, what would that server system have for an output requirement? Thinking of just a Microsoft server. What does a server do? Okay, so it can serve websites. Okay, so it can store data and be retrievable. So SQL Server is a big part of it. Your very basic server, one reason, I would say the one basic reason to have a server is the Active Directory. You've got 100 people, and to manage 100 PCs for authentication and system updates and group and policies on the system, you could go around to each system individually, deal with it. Give you a lot of job security. You're saving money on a server, but you're spending a lot of time, or have a team, just keeping things updated. Now, you could actually manage a group that way if people knew enough and you had perhaps some software running on those systems. That would be automatic updates, antivirus getting automatic updates. If there's only one person logged in, you're probably fine. But as soon as you start needing to share resources, people have to know, okay, how do we create network shares? Okay, go around, adjust the network sharing. Oh, it's changed. Got to go back around to the 100 systems and update them individually. And that's the big spiel about here's why you need Active Directory. You can manage all your systems that have been connected, we call it joined to the domain. You can manage the accounts and the policies. That's a huge part of Active Directory, is group policy, that you can require from one screen, from one server, anyone in your domain, which is all the computers now connected to the server, you can tell them, hey, today everyone has to change their passwords. Boom. The policy goes out, and the next time they come in, all those changes are made. So that has to do with some processing that it does, some input. It gets and handles passwords. It handles interaction with your systems that are joined to your domain. Performance. Got a little hit on performance. I don't know if you've noticed this or read about it, but if you have systems that are, well, we have a roaming profile, when people log in, the login actually takes longer than if they were a local account. But there may be other performance things that are way more beneficial above the longer login time. You have so much more capability in centrally managing, and here's a huge part, security. From the group policy, you can enforce password policies. You can be logging activity on all those systems, checking for either odd activity, malware, or even employee activity that should not be happening. Data, you have a little bit more control when you have the centralized server. So those are the kinds of things that you might put for system requirements. But a system requirement in the generic term seems obvious. It's what your system needs to do to be a successful system. Some basic requirements, not mentioned here, are your users, your customer. You want your customer to love your system and use it. And when they love it and use it, they will pay for it. Because the bottom line is, you're producing a system that will have some kind of return on investment. And that's a big part of your senior project, is justifying and keeping track of, here's the expenses, here's why we should build this system that's going to cost this much because of the economic benefits you're going to have from it. So that's a little help with this question. Now let's run to the JAD and RAD and review the differences between those. We discussed those a little bit last time, but let's go down to the JAD and RAD part, where we're thinking about how in the world we're going to organize this team. These are the three main ones that people know about out there. Agile is the most foggy, and we watched that little video last time, remember, where it said Agile is more of a philosophy than an actual method. It's a way of approaching the problem. Essentially, like the word says, being very flexible. There's no defined, here's what Agile is. It's the priorities. Priority of, do you remember some of the priorities that Agile video mentioned? The priority in Agile. Remember the one thing about, do you meet the customer's needs short term or long term? It's a short term. Don't worry about, the particular example he gave was, you could design a strong database design that would enable future stability, higher capacity in the future, and spend more time doing that. Or you could get that one piece of data into the database now so your customer sees something working next week. You would get the customer to see the immediate effects. Not that you wouldn't do the, hey, provide a stable database, but your priority would be get something working for the customer, and then in the background either buy or have someone else build or propose that as a system of having a stable database back end. And the idea is to be as efficient as possible in your use of time, because you've got people working with you and you want to get done. And the main difference between JAD and RAD is, both of them bring users into the design process. JAD brings users into the design process. The old school method, according to the book, is, the IT group used to come up with ideas, they'd get input for ideas, then they'd go off into their corner in their lab, and the smoke and the electronics would be beeping away, and the lightning, and the scientist comes out with the wonderful new system after they've worked on it. And we expect the users to jump up and down and joyfully use the new system. Well, because systems are getting more complex, and the user, and especially with Agile, the user requirements are so important and may change or may not be clear at the start, but as they're involved in the design, they will make it clear what we really need. So users/customers involved in the design process. And Agile involves them even more. But the thing with JAD, and here's part of the questions here, is what are JAD and RAD? What is the difference? With JAD, it's the design process that the user is involved with. You have them in special meetings. Let's nail down exactly what you want, Mr. Customer. Whereas with RAD, it's the whole life cycle, and the users are involved in all of that. So JAD, primarily users, heavy in the design, and then they can go home while you then implement the system. Where RAD says, okay, we're all going to work together. Customers, you don't leave until you have your system. Of course, they may be 50% of the time, more likely. As much as you can, you want to get full-time commitment from people. But some people, they just can't be full-time commitment. And Agile, again, it's a philosophy, and that's why they say it's methods. There are many Agile methods that basically intense, constant interaction between developers and users through the entire life cycle. But remember, with Agile, the life cycle kind of changes. It's more of, let's get the prototype, let's get the initial version out there right away, and that's our month's job. We get that part working. Then we go back and say, okay, our next milestone is another shorter milestone. And hopefully having the users even using a system that doesn't have all the features you're promising in the final system. But again, Agile methods, depending on what method you're using, such as the Scrum, that's kind of depicted later on here. This Scrum is where you have similar kind of team with sessions, specific targets for the week. And I'm not sure why this moved that image out of the way. You emphasize specific times to do certain things. And you mentioned in that little video, some will use little sticky notes to put them on the wall. But that doesn't mean that's the only way to do Agile. It's a way of making clear to everyone what they need to be doing. So I'll put that little caption up there. So they use rugby terms. It was probably invented in England, or maybe, as they describe how the team is producing results. There's your little Scrum team. But Scrum is just one of the types of Agile methods. It's one way to do the Agile philosophy of getting things done quick. And they have these things called pigs and chickens. Do you know the difference between a pig and a chicken? Thinking of breakfast, the chicken was involved, the pig was committed. That's where they get the pigs and chicken. They are completely committed. They're the owner or the customer that's going to be stuck with this. Chickens are involved but not as committed. They're stakeholders and other users. Okay, so there's that help with the answer to the question, what is the difference between RAD and JAD? And what's the main advantage of team-based methods? Well, the claim is they can get things done faster. And remember, the users involved. And just a open-ended question here for you. Besides having their input into the design of your product, what is another advantage? Think psychologically. What is a psychological advantage to having your users involved? Yeah, they feel that they own the product. Ownership. I have some input into how it was built. I'm going to be more interested in working with it, and I'll be more patient with it if there's bugs in it that need to be fixed, because I've worked with the team, I've made friends with the team members. That's part of it, the personal interaction that they claim millenniums aren't so good at, or generations coming after that, because it's so much tied to your electronics. Don't forget people skills with your customers, especially. With the team, they should come kind of naturally. You work with people, you put up with the grumpy guru on the team because you know they produce flawless code. With their customers, you be super friendly and listening to their input. There's that sense of ownership, the psychological advantage. But besides the psychological part, it does produce more accurate understanding of what the goals of your system are, because they're there, and hopefully they're the right users. You don't want to get users that have not used the old system, or maybe they've used the old system but they don't have the big mission of the company in mind. You want to be sure that they're someone that really is committed to the success of their company and the success of your system, being convinced, of course, from the planning part of it, that this is a necessary system. They're not just thrown onto this team because someone needed to go work with this team and they're not convinced you even need the system. You want to make sure that before you even have them on your team, they are convinced it's an important system to have. Not just because we're paying a lot of money for it, but they understand why it's going to help their company. And you'd be surprised how many people are pretty cynical, and at first you come across like, man, why are they even here? They're so cynical. Sometimes it's just their personality, and they really do care about the system, but their way of expressing themselves is in a more cynical manner. Okay, so let's jump ahead to, as we learn about our system, how do we ask the right questions to find out what goes into our system? So let's jump down to some slides here about the way to get answers. We'll come back to the modeling tools, and we're going to be doing more of those in future chapters of the actual modeling tools, the various diagrams. But we want to find out about what we need to go into our system. I'm jumping ahead to the fact-finding part, and then we'll come back here to the to the total cost of ownership. But in the fact finding, remember we've come up with some idea of what we need to know about our system. Sometimes, though, we need input to make sure we haven't missed something. You'd hope that in the planning stage we have the full list, but you may not have everything in the details. So, referring to that server idea, we're hiring someone to get educated about servers. What business functions are going to be supported by the proposed system? In our discussion, we mentioned website, databases, authentication into your computer systems, which is more of everybody needs a computer. It's an enterprise-wide thing. But a server would enable that to work more efficiently. A basic need of everything in my company, you're providing with a server support of multiple business functions. And we'll come back to the total cost of ownership. What transactions will the system process? Again, making us think about the details of our system. Thinking of a server, what kind of transactions does a server manage? Samuel, in authentication of computers, what transactions are being processed? What kind of transactions are there when a person logs into a computer and authenticates in their logon? Yeah, we got username and their password. That's a transaction that goes between me and the server as they log in. What happens as they're logging in? What other transactions are going on? Think of a centralized login where you have roaming profiles. Would you expect when you're logging into a system to see your same desktop when you log in to your system? And how about your own documents that you have saved? Will they be showing up for you on that system? So transactions, it's not just here, you have the right username and password. Okay, you can log into this computer. But to show you your desktop in a transaction and a login for just a server that uses Active Directory, the transaction is I'm sending you all your profile data, your documents, your personal documents, are being sent to that computer that you're logging in, and that's a reason those logins take long, is they're doing a lot of transactions with your profile when you log into a system that has a centralized login. So servers are handling a lot of transactions, not just saying, oh, by the way, I know that that's a valid user on your system. It's okay, here's a valid user, here's their desktop, here's their document files, and if they do it right, those things happen very efficiently without a long delay before you can actually get any work done. And that's a tough thing for servers and the whole domain control. And I've even noticed that other systems I'm working on that they have it very efficiently, but still, sometimes the login is a 5-minute login. Other times it pops right up. So, in the fact finding, what we're looking for to answer the question is various types of questions, and what are the 5 questions. So it's split up into a couple of questions here. Question 1 has what are the 5 questions typically used, and then down here, give me examples of a closed, open-ended, and range of response question. So those 2 are related, question 1 and 5 in the homework. Let's first look at the 5 questions asked and then come to some examples of closed-ended, open-ended, and range of response. So, the 5 types of questions normally asked are these. The first 5, the Zachman adds the why. That's the part of that. Here. The Zachman framework, what's the additional question in the Zachman framework? So here's the first 5 questions